use it every time. Hi, honey.
Okay, here we go. All right, there's a few things I'm going to tell you about the periodic table. There's a reason that the periodic table was set up the way that it is. This whole process, it walks hand in hand with the way that the periodic table is set up. So this is what I want you to know. An energy level, okay? Energy levels are represented by rows, okay? Energy levels are represented by rows. So everybody know what a row is? A horizontal line, okay? So like rows on the periodic table, right here, right here, right here, right here, right here. Does that make sense?
Sure. Yeah.
So, yeah, it is by number. And the number is 1, 2, 3, 4, 5, 6, 7. So if you look down the left side of that periodic table that's on the wall over there, see how there's numbers that go down the left side? The one on the wall? Okay? So energy levels are represented by numbers.
Are the bottom two rows are those?
Okay, so these bottom two right here, these actually have been pulled out of right here and right here.
We can't see.
Okay? So see how right there it says 57 through 71? It is, yes. It has basically been just pulled out so your periodic table isn't 35 feet long. Okay? All right. Now, a couple other things that you need to understand. Whenever we look at this periodic table, we are going to write an electron configuration for a specific element. Every other element is going to represent an electron. Okay.
Wait, can you say that again?
When we write an electron configuration for a specific element, okay, every other element is going to represent an electron, okay? And look, here's why. Here's why you can think of it like that. Hydrogen has 1 electron. Helium has 2. Lithium has 3. Beryllium has 4. Boron has 5. Carbon has 6. Nitrogen has 7. So as you go down the periodic table, it increases by 1 electron each time. So you don't really think of them as elements at this point. You think of it as representing 1 more electron than the atom before it. Okay? All right. Now, a couple other things I want you to know. All right, outline this part right here.
Get out the highlighters.
Okay? You can use a highlighter if you want. All right, this part represents your S sublevel.
Wait, including hydrogen, right?
Including hydrogen.
Awesome.
Represents your S sublevel.
I hate being left-handed.
Oh, I think I get it. That's what you meant by all the letters, like S, H, whatever the other ones were.
All right. Next thing, this section over here, this represents your P. Okay?
Wait, what about the ones on the bottom?
We're getting there. Okay?
I think I just missed it. I need to do it.
Go. Nice one, BC.
It's fine.
No, literally, I messed up. I did the wrong ones. I did. I promise. Are they in the back?
All right. No, they're right here under my arm. You're going to have to use that one and this one for tomorrow's game.
Why?
All right. This part right here in the middle,
P.
this represents your D sublevel.
Oh, I know.
Wait, so just all the other ones?
All the ones in the middle section. represents the D sublevel. Okay? And what do you think these bottom two rows represent? The F.
Yeah, but then.
Oh my gosh, slow down.
But they're in the middle.
Well, that's still, it's a separate section, but it fits right there, but it's not part of the D, it's part of the F. All right,
So the bottom's F.
bottom is F, bottom two rows.
Coolio.
Now, essentially what this means is that wherever your element is, okay, that is where your highest electrons will be, okay? So like take sulfur, for instance. Sulfur's highest electrons would be in the third energy level, because it's in the third row, and the P sublevel, because it's in the P.
So where's that?
Okay? F is the bottom two rows.
Okay.
All right. Now, everybody look at your paper for a minute. Okay?
I'm not small, don't talk to mine.
All right. Now, here's what you have to understand, okay? Every time that we write an electron configuration, we are going to start from the top. No matter which atom we're actually doing it for, we're always going to start with the top, okay? And walk our way through the periodic table just like a book, left to right, top to bottom. I'll explain this to you as we go along. So the first element that we're going to do is sodium. Okay, this is number 1 on your packet right here. So sodium is right here. Now, the first 2 electrons are always going to start in the same spot. Okay? There's 11 electrons we have to place in sodium. So you're going to start up here at the top. So the first 2 electrons, okay, and actually, I should have done this. Helium, actually, you can fit over here because this actually is part of the S. All right.
Just messed up my chart.
It's fine, okay? You're not turning this in, anything like that. Okay.
Literally, I just.
Listen, don't freak out. Calm down. All right, listen.
Is helium S or P?
Helium is technically in the S. All right.
What you just said.
You screwed me over.
That was my fault. I should not have outlined that.
You're
Okay.
Wait, so hold on.
Yeah,
There's a-
Helium is in the S.
Listen, guys, there's a reason why it fits over here, but for this purpose, it's
I can-
considered
So I can color
Right there.
it in green like my S. is.
sure. Okay. Now, here we go. All right. First 2 electrons that sodium has. Remember, each element represents an electron. So first 2 electrons that sodium has are going to be in the 1s.
I thought you could go every other.
What do you mean every other?
You
You
said
said
every other.
every other. Like when you were doing the like.
You said every other electron.
Yeah.
Yeah, you're contradicting.
Am I crazy or thinking?
No,
How
he
did we get
did
one
say
S? That's what I
All right,
thought.
look.
Yeah, so did Zan, and Zan's
When you go to a concert, where are they always going to sell out first?
The program.
Near the stage. This is the nearest to the stage you can get, the 1s. That's as close to the nucleus as you can be. First energy level, S sublevel. Okay? So the first 2 electrons that are in sodium, and really in any atom, they're going to fit in the 1s. First energy level, the S sublevel. Okay? And the S sublevel can fit 2 electrons. So you would put 1s2. Okay? And look, everybody look at how many columns the S section has. How many does it have? Columns.
2.
It has 2. There's a reason for that. Because every S sublevel can hold 2 electrons. Okay? Look at how many columns do you have in the P? 6. That's because
Six
the
electrons.
P can hold 3, or I'm sorry, it has 3 orbitals. It can hold 6 electrons. Okay?
Okay, I was like, there is no
Sorry,
way.
sorry. So, here we go. 1s2. Now, keep walking across. There is no P sublevel in the first energy level. All right? That's why there's nothing here. So, we go down to the second energy level. All right? What is this? What energy level is this?
2.
2. What sublevel?
S.
2s. How many electrons?
2.
2s2. Okay?
And then
Now, keep going. Going across. Now, what is this?
That energy 2.
This is your second energy level. What sublevel?
P.
P. And how many electrons? 6.
hold on, how did we get all the way over there?
I
Okay.
should have paid attention.
My brain hurts.
Look, it's really not that bad once you start doing it. Okay, I promise you. Now, you have 6 electrons right here. Sodium is the very next one. How many electrons does sodium have? 11. Well, look, count up your superscripts. 2, 2, and 6. That adds up to 10. You have one more electron that you have to place. And that's going to go in the third energy level, the 3s, because it's the S sublevel,
Yes, 1.
3s1.
But where'd you get the 1 from? From the sodium?
So it has one more electron that has to be placed.
Yeah, but where'd you
That
get
adds
it
up
from?
to 10.
11 minus 10.
That's how many.
No, I know, but where'd you get the electron from?
Yeah,
You mean
Well,
sodium has
Well,
11
sodium has
electrons?
11 electrons.
That's what I just said.
It's the 11th element.
I don't understand your question, I guess.
Sodium just has 11 electrons.
Yeah,
Just
I mean,
does.
yeah, I mean it's kind of like you have 10 fingers and toes. Like,
I only had like 5 toes.
well, then that would be
Hey,
your
be special.
characteristic. But that's what sodium has. Like it has 11 electrons in it.
Mr. Harrington.
Yes, Jimmy.
So I don't get what was the point in doing all of that when literally it has an 11 right in the top left corner of it.
Because it shows you. Look, listen. It shows you the most likely location of finding electrons in the atom. So what this is saying is that there is a likelihood that you would find 2 electrons in the S sublevel in the first energy level, 2 electrons in the S sublevel in the second energy level, 6 electrons in the P sublevel in the second energy level, and 1 electron in the S sublevel in the third energy level.
It's like Mrs. Theory's representation with the plot.
So,
Oh my gosh, I know.
but why can't you just know the amount of electrons? Why does that?
Well, I mean, you should know that, but this is a more specific way. I mean, it's like, it's the difference of, say, like me saying, all right, there's 23 people in here. Okay, that's knowing how many there are, but where do they sit? This is kind of like where they sit, or where they are most likely to be found. Okay, does that help?
Yeah.
All right.
It's like doing a seating chart.
A little bit, okay? A little bit. All right. Now, let's do another one.
Yeah.
Do they all start with 1s2?
All right. I am going to go to. All right, we'll do iron.
They always start with 1s2?
Yes. Always. That's so listen, that's the good thing about these electron configurations. They all start the same way. So if you've done one, they're all going to start the same way. Okay? So if we look at iron, it's further down than the sodium was. Okay? So we can go ahead and start, put the same thing. 1s2, 2s2, 2p6. And then when we get to 3s, how many electrons are we going to have in iron's 3s? Because it's further down, there's 2. So it's going to be 3s2, and then keep going over here.
Where'd you get all
So
the-
basically,
Oh, you just okay.
Yeah, I just copied what I had for
further
sodium.
down it has, it'll just repeat the elements before it over and over.
Yes. If it's further down, you're just going to repeat it until you get to that element, and then it'll be different from there.
Okay, cool beans.
All right. So 3s2, and then what comes next?
Then you have to do 3 P's.
3 iron is Fe. 3p6,
Where is it?
right here. 26.
Jimmy.
Okay?
What? I said one.
All right.
Jimmy just saved himself.
Listen. Now, here's where it gets complicated.
Oh, great.
Okay? Here's where it gets complicated.
You said it like 4 times.
Well, it gets more complicated.
Oh, bro.
Okay? So, every time that you go to a new energy level, you gain a new sublevel. So, in the first energy level, you just have the S. In the second energy level, you have the S and the P. In the third energy level, you should have the S, P, and D. But look, third energy level, there is no D sublevel right here. Do you see that? Third row, there's no D section.
Now there is a level 4.
But it doesn't come in till the fourth. But if you think about that, it should come in on the third. All right, here's why. These electrons don't necessarily fill in order of lowest number. They fill in order of lowest energy. So you could have a sublevel that has a lower energy level number, but it actually is at a higher energy than another sublevel. But look, I know that sounds confusing, and it is. But the periodic table takes that all into account. So the only thing that you have to remember is that the D sublevel is one number behind the row that it's in. So if this is the fourth energy level, this is what? The 3D. It's one behind. Okay?
Oh, so the D is like supposed to be in the third.
So this is the 3D. Okay? This would be your 4D, 5D, 6D. All right? So here we go.
D is one below where it should be.
D is one behind where it should be.
When you write it, you always write it.
We got a 3P before 3P.
Like you always write the.
No.
Wait.
No. I'm going to show you that here in a second.
D though.
All right, listen.
If you're going left to right, it's above.
Listen. So this is what you would do. This would be the order of filling. It'd be the 3s2 right here. Then it would be the 3p6 right here, that's what we put. Then it would go to the 4s2. 4s2,
That's an
And then it goes back down.
okay? And then it would go back to the 3D. All right? 3D, and it's 1, 2, 3, 4, 5, 6.
Wait.
So it'd be 3D6.
Because iron is big brain.
That's supposed to be
Oh, because you only do.
What
it.
time
I
is
mean,
it?
that, bro.
It's almost time to go.
All right?
No, it's not.
We still have 30 minutes.
So
Oh, so it's-
Better than 2 hours.
Wait, so does this add up to 26?
yes, if you add 2, 4, 10, 12, 18, 26.
Oh, shoot, I have not been writing
So
Okay.
wait, I have a question.
Grace.
So, okay, when we went from, 3P6, and then we skipped to 4, 3,
Yes.
2, and then 6. When we go back to 4P,
Yes. Yes. So the S and the P are always the same as the row that they're in. The D is the only one that's one row or it's one number behind the row it's
so
in.
after 3P6, we would add the,
Right, it'd be the 4P.
oh no, 4P.
Yeah. Now, I'm going to tell you this, but I will never test you on ones that contain F sublevels. Okay? And there's a reason for this. Depending on which periodic table you look at, if you find different periodic tables, the electron configuration may be a little bit different depending on the periodic table. The rule that I'm going to tell you is this. So the D sublevel is always 1 behind the row that it's in. The F sublevel is always 2 behind the row that it's in. So if this is like the 6th row down here, this is actually the 4F. And if this is the 7th row, this is actually the 5F down here at the bottom. Okay? All right. Lily, did you have a question?
This is gonna be like a big request. Like, is there any way you can like write down or type out like the steps? Like at some point.
Well,
Just watch
I
the
mean,
video on Google Classroom.
yeah.
Yeah, because I need like written instructions.
Google.
Jimmy, so here's the thing. The best thing that I can probably give you is just like a ton of repetition.
Alright.
So we will do like a bunch of examples. But as far as like written steps, it's complicated. So it's almost one of those things like you just have to sit down and do it.
I just watched the video.
All right, let's do one more example, and then I will give you the rest of the time to work on your project. Okay? Let's do bromine. All right, which is right here. Okay? Now, here's the thing. Up until where iron's at, bromine's going to have the same configuration as what iron does. So it'll be 1s2, 2s2, 2p6, 3s2, 3p6. And then we get to 4s2.
Because it's the same as the one before.
It is. It's the same as irons up to that point.
So he's just copying and pasting basically.
And instead of it being 3d6,
310.
it's going to be 3d10.
I actually understand.
Okay? And then bromine is going to be what?
Wait, is it
4p5?
4p5.
whatever he said?
Jimmy.
Okay? Because it's in the fourth row, P sublevel, it's the fifth one over.
That's what I was asking you earlier.
I can't see.
Like about the
Go
sodium.
back, go back.
Because you put 1 instead of 2 because it's 1 and 2.
Oh, well, yeah, it's the first one in the S sublevel.
So you
Yeah.
put 1.
Okay, yeah, I get
Yeah,
what
I
you're
know
saying.
exactly what we're doing.
All right?
Casey, you want to come help me with one of them?
I don't know what we're doing.
Yeah, it was hard, guys.
Okay,
I literally wasn't.
so look, we're going to stop there. All right? We're going to leave that where it is. Okay? We're going to come back tomorrow. We're going to do some more examples, and I'm going to give you these last 30 minutes that you can work on your project.
Mr. Harrington, did we do good, decent listening today?
You did decent.
I thought today was pretty good.
I mean,